Hello, Assalamualaikum. My name is Nur Safi Hanani binti Satar. My ID is EA18027. My lecturer name is Dr. Badruddin Muhammad. I would like to introduce about our project Microprocessor. This is my abstract. In this report, we will explain about the project that we had choose by providing a little bit theory about ARM Cortex-M0+, Proteus 8 Professional, and Kill Vision 5 program specification. Coding for the project and a bit discussion regarding to the result. However, few references have been used in order for us to get good condition. In addition, thank you for Dr. Bada because absolutely give a big help to this project. Introduction, I will explain about ARM Cortex-M0+. In this project, we have been assigned to design, build and test with ARM-based system, which is we need to create or develop a program that can be applied in our daily life. In this project, we are using ARM Cortex-M0+ to build, design and test this project. ARM Cortex-M0+ processor is a high performance and energy efficient ARM Cortex. ARM Cortex-M0+ energy efficient because it is optimized a development with a core pipeline of just 2-stage enabled Cortex-M0+. To achieve a power consumption of just 12.2 microwatt per megahertz will increase the performance to 2.42 core mark per megahertz. The Cortex-M0+ processor builds on the very successful Cortex-M0+ processor, retaining full instruction set and tool compatibility, while reducing energy consumption and increasing performance. Along with Cortex-M0, the exceptional small silicon area, low power and minimal code footprint of this processor enable developers to achieve 32-byte performance at an 8-byte price point by passing the step to 16-bit device. The Cortex-M0+ processor comes with a wide selection of options to provide flexible development. Cortex-M0+ has a lot of benefit compared to Cortex-M0+. Cortex-M0 on the benefit is low power consumption when used. Cortex-M0+ is the most energy efficient of all ARM processors. The Cortex-M0+ achieves a power consumption below 4 microwatt per megahertz, which is 40 LP process based configuration, while reaching a performance of 2.46 core mark per hertz. 2.46 core mark per megahertz. Other than that, Cortex-M0+ is also versatile compared to other Cortex. This is because the Cortex-M0+ include optional functionalities that allow user to reach an optimal fit-for-purpose solution for a broad range of applications. These include the single-cycle input or output interface for faster control, the micro-trace buffer for enhanced debug, and others which are common to all Cortex-M processors, such as the memory protection unit MPU and the relocatable vector table. Last but not least, Cortex-M0+ also fast in time to market. The Cortex-M0+ processor is binary compatible to the Cortex-M0 and is advanced binary compatible to all other Cortex microprocessor, making software reuse and a real advantage. Developers also benefit from ARM partnership, extensive ecosystem and embedded tools, software and knowledge base. This is our flowchart for poly-slide. First, start and then initialize, push button, LED and buzzer, and it will be spread to 3 type of process, which is daily petrol. When daily petrol, PBI will press. When it's called VIP, PB2 is pressed. When emergency, PB3 is pressed. Then daily petrol will run in normal speed for LED1 and LED2 and delay 5 seconds. For escort, will running in fast speed on LED1, LED2 and LED3. Delay 5 millisecond. For emergency, we're running full speed on LED1, LED2 and LED3 and delay 3 millisecond, then the siren will rings. And methodology coding. Okay, from here we can see we will start with hashtag include. This is our chips. Then void delay in I for I0 or I less than n and I plus plus. Okay, this is initialization coding. This will enable clock to port B bit 10 and port D bit 12. Okay, this is PBI. This coding is for PBI. This one for PB2. Lastly PB3. Okay, PB1 for patrol. PB2 PB2 for VIP and PB3 for emergency. Okay, this coding about switch red or green LED off, and then this enable PTB 18 or 19 as output. This one switch blue LED off. This one enable PTDI as output. Okay, this one LED1, LED2, LED3 and buzzer. For this coding, add PTBB 11 to existing PDOR register setting. For this, add PTB8 11 to existing PDDR register setting. This coding for port D pin number 3. This one for port D pin number 6. This one for port D pin number 7. Okay, here LED1 on, LED1 off, LED2 on, LED2 off, LED1 on, LED1 off, LED2 on, LED2 off, LED1 on, LED1 off, LED2 on, LED2 off. This one for normal push button, and this for PB2. Same process, LED1 on, LED1 off, on off, on off. Then same, also same. Okay, here PB3 buzzer on, LED1 on. Okay, why buzzer on? Because when emergency, the buzzer will on. And this LED1 on, off, on, off. Okay, behind the else if we will repeat the same LED coding, but difference PB3 because we have buzzer on. This is for traffic light. Okay, we will use Atmel AT89C51 crystal, capacitor, resistor, switch, BCD to 7 segment decoders, traffic light, timer and jumper or connector. Okay, this coding for one junction. Okay, here is for one junction. Same, start with hashtag include. Then this one, the chip, the name of chip. Okay, void delay. This is about delay. Void light, YG because yellow and green. Then void light R because red color. Okay, sancha A, that is time. And sancha T, this is about light. While one, like Y and G, yellow and green. Y and G for yellow and green. R for red. Okay, here is the coding. Okay, this coding generates multiple of 1 millisecond time delay at os frequency of 12 MHz. Note maximum passing parameter is 65535. Maximum time delay is 65. Okay. This coding is to generate multiple of 1 millisecond time delay at os frequency of 12 MHz. Net maximum delay is 65.536 seconds. This is for junction 1. This is coding for junction 2. Almost same the coding. Okay, here is circuit for junction 1. We have chip, crystal, capacitor to capacitor, resistor, this is switch, this is timer. This is timer. This is decoder, and this is traffic light. For junction 2, junction 3 traffic light. This is circuit for 3 traffic light. For circuit 2, same. We still use chip, Atmel, then capacitor, crystal, resistor, switch, and 3 traffic light here. 1 timer and decoder. Okay, when we run the kill, we got 0 warning and 0 error. This is our coding that I explained before this. Okay, this is the result for one junction. Okay, this is the result of junction 1. Only 1 traffic light and 2 timer. And then same chip, crystal, capacitor, decoder, timer. This is traffic light. The upper is red, this one yellow, and lastly green. Okay, I will play the video. Okay, for green it will be at second. The timer will count. And then yellow only 2 seconds. Will be 14 seconds. And the result will be continuous, okay? Okay. Continue to yellow. Okay, this one for 3 junction. Start. Okay, for traffic light 1 green, and the other traffic light will be red. After that yellow only 2 seconds. Okay, red. Okay, after this traffic light red, it will be the second traffic light for green for running, and then yellow and red. And when the traffic light 1 and 2 are red, the traffic light 3 will running. Okay, now green color, green light, and then okay, yellow light, And lastly, red light.
My name is Siti Naraini binti Cik Uhaimi, EA18120. Today I will present about our project. Our project discussion is, for this project we managed to design, construct and test a simple ARM-based system by using Kale microvision, microcontroller and Proteus. We also managed to design I/O device and interface with the ARM-based system, and we managed to apply this outcome. Then we can develop a programming using an assembly language or high-level language, and we apply this in the embedded development. We can gain knowledge how to analyze and troubleshoot the system using various development tools by doing this project. For the conclusion, at the end of the project, we were able to achieve the aim of solving a solution to a current real problem, which requires the student that need to understand the operation and the basic use of a microvision, microcontroller and Proteus. So we can see that the microprocessor is the one of the biggest and crucial influences that play a big role in industry in order to solve and be the solution of a real problem in our daily life.
Okay, the reference. Firstly, I refer to UK essay, which is published on 1970. The topic is traffic light controller using microprocessor. The publisher is ukessays.com. This is the link. Secondly, Frank Donald 2014. The topic is 4-way traffic light using AT51 controller and 7 segment. The publisher is Gadgetronic. Thirdly, NXP 2020. About topic FRDM MKL25Z, Freedom Development Platform for Kintis. The publisher is nsp.com. Okay, here is the link. And fourth, Dilip Raja. The topic is flashing police light circuit. Publisher is Circuit Digest. Fifth, Sheikh Zain Nasir 215. The topic about LED blinking project using AT51 microcontroller. The publisher is Technopreneur. Okay. And then Y Song 218 police light using 555 timer. The publisher is Electronic Hub. Okay. Then 1, 2, 3, 4. I refer here too, but we don't have exact info about who create the link.